Hello everyone, we are back again with the another prediction model. So today we will gonna be building a car price prediction model. So for that, I broke these steps into like 1, 2, 3, 4, 5 steps. Like first one will be data import, and after that we will gonna be doing some simple EDA process. Using the EDA process, we learn a little bit about data like data size, data describe, or data info. After that we're gonna be jumping through the feature extraction, because all the features or data is not needed from the data set. So we're gonna pick those data that is only be needed to feed on our machine learning model. After that we're gonna be building our model, and using the R2 score we're gonna be comparing the model optimization. We're gonna be again building some other different techniques, and on the last we're gonna compare which one is better. So okay, so let's jump into Jupyter notebook. So at the very first beginning on the Jupyter notebook, as you can see, I first defined some libraries, and after that I imported the data set on the data variable. So what I did here, I import the data as CSV file. So now here I will gonna run it. So let's check it's properly working or not. So I'm gonna pick here data.head. So as we pick data.head, we can see that 5 rows is visible. The data is actually bigger than these 5 rows. Actually, for the head function, the first 5 is showing up here, and the other column are also showing. If we see data.shape, as you can see, 301 rows are there and 9 columns are there. So up to here it's okay. So we're gonna be doing here the EDA process, as I mentioned. Sorry. Okay, so for EDA, okay, let's change it up here. It's looking a little bit weird. Okay, so now for the EDA process, what we can do here, we can use describe function. We can also use info function, data dot sorry info. We can also use like other functions are coming up here. We can see is there any null value presented on our data set. We can also use the correlation SNS heat map for all those. So let's do it. So for first, describe is coming, so we're gonna be hitting data.describe. So for if we see about data.describe, only the numerical columns are coming. Other columns are present as object like car name, fuel type, seller type, and transmission. But without all those, others are coming on numerical form. So here the data is divided into many rows like count, mean, standard, maximum, 75%, 50%. The counts are over there, as you can see. So after data.describe, we can hit into data.info. So all info are coming. As you can see, the data types is coming as 3 categories mainly: float, integer, and object. So all those columns, only the data is categorized into 3 form. And after that, as you can see, memory usage is 21 KB, and yes, like total 9 columns are there, and there is no null value. It's showing there is no null value. After that, we also gonna be checking its and is there any null value using is NA function. So I'm going to quickly hitting on is there any null value or not. So as you can see, for the first 5 rows and last 5 rows, there is no null value. False means there is no null value. But we don't know, like in between the rows that are coming has null values or not. So to check, we can simply be doing calling a sum over there, and as you can see, for on the left side all of the columns are coming, and for each of the columns everything is coming 0 0 0, means none of the columns is containing any null values. So we can do a little bit another thing, like if we call sum again, it will sum it up everything and will give one answer. So yeah, it's coming 0. It's a good thing that there is no null value. If we get any null value, we need to drop that null value. There is no value here. So what if we get any null value? If we get any null value, we need to drop it. We need to not drop that null value. So as there is no null value, we're gonna switch to other process, like after that, after the EDA, the feature extraction is coming. So before feature extraction, I need to convert some data into some object, from object to numerical, like car name is here. It is on object from, like strings are there, and for fuel type is also there, seller type is also there, transmission is also there. So I need to convert those into numerical form, like car name, sorry, car name. We also have like fuel type. We also have fuel type, also seller type. And after that we also have transmission. So all those four are there, they are in object form. So to feed all those data into our machine learning model, we need to first convert them into numerical form. Then that, for that time, our machine learning model will work. Our machine learning model won't work for all of these like object form. So what I'll gonna do right now, I'll gonna simply convert them. So if I pick fuel type, like data, so as you can see, for a fuel type, some categories are coming. Mainly we can see two categories, like diesel and petrol is coming, and in between there is a chance that other categories also may come. So what we can do here, we can use data, we'll call the fuel type, sorry, and for fuel type we can use value underscore counts. So it will count all the values in categorical form, and it will show us, here will be dot, okay, so values dot count. Yeah, there is the answer. Like we have petrol, the values count are 239, and for diesel it is coming also 60, and for CNG. So as you can see there, if we see in categorical form, there are mainly three: petrol, diesel and CNG. So what we can do for other, we can use the print, because we're gonna be doing multiple, all those into multiple. So we're gonna hit print over here, and after that I'm gonna just copy it and paste. And what I'll do, I will simply check the other forms, like seller type is here, so I'll simply replace it, also copy it for another time, simply paste it, and transmission is also there. Yep. So as you can see, for other columns we have for seller type we have dealer, we have individual, and for transmission we have manual, and we have automatic, and for each of the columns the value counts are there. Now what we can do over here, we can convert all those into numerical, like we have petrol, diesel and CNG. For the fuel type, what we can do, we can use petrol as, we can define petrol as 1, diesel as 1, and CNG as 2. Like it is for this technique it is converted into numerical, and it will work smoothly on our machine learning model. And also all of this, like we have dealer, we can convert it as 0, and we can also convert the individual as 1, individual as 1. So it will work like that. So each of the time the data we are getting as petrol, on that it will be initialized as 0, and we are, if we are getting as diesel it will be initialized as 1, and if we are getting on CNG it will be initialized as 2. And be on during the prediction, the correlation matrix, if it get as 2, it gonna be you be using CNG. So what I'm gonna be do here, I'm gonna clean it up and simply use call the data, and I'm gonna use the replace function over here. So we are getting the fuel type inside. So for fuel type we have petrol, diesel. So I'm gonna call the petrol. For petrol, let's hit it as 0, and for we have also diesel, let's initialize it as 1, and for CNG let's initialize that as 2, and we're gonna be using in place to boolean true. Okay, so here what we did, we replaced the fuel type column into there are 3 types like petrol, diesel and CNG. For petrol we initialize it as 0, diesel as 1 and CNG as 2. Let's try it's working or not. So we're gonna call data fuel type. So if you call as you can see, like all those, okay, it's not converted, I think. We need to check it again. Data dot replace. If we hit fuel type here, it should be replaced again. Okay, the attribute full fuel type, sorry. And let's see using data dot head. Okay, sorry, I did a mistake over here. We need to use not the small letter T, the big letter T over here. Now let's push it. Let's check again. Yeah, as you can see now it is converted fuel type 0 1. Let's pick fuel type over here. Sorry for the mess. As you can see now it is converted to 0 1, like 0 1 is showing. For CNG it will be showing as 2. So now let's move on to other columns. I'm gonna simply copy it just over here and gonna select now seller type. I'll pick seller type, and for seller type we have dealer and individual. I'll gonna initialize dealer as 0 and individual as 1. So there is no need of 2 here because only 2 categories are here. So for 2 categories we'll be using 0 and another is 1. So we have another one. For another one we will be using transmission column, and for transmission there is manual and automatic, and automatic is there. Manual for I used a 0 and for automatic I will be using 1. Now I will clean up here because we have 2 categories only. So for these also in place equal to boolean true. Okay, let's run it at this one, also this one, and let's check. Yeah, as you can see, like seller type and transmission also converted. If we so here the last one is left with his car name. Let's check car name. Okay, shit, I'm doing this mistake again and again. So if we check the car name here, we have different type of cars. There is no way that we can use any category steps like before we used 0, 1 or 2 something, because there are many kinds of cars are here. So what we're gonna do, before feeding on to machine learning model, we have to drop it. We have to drop this one and we can feed that one. So it is aligned with the index, so we can pick later. Than after the prediction we can check using the index number also, like each of the car name have their unique index number. So during prediction we can use the index number and check the car names also. So what I'll do here, I will gonna split the data set into x and y axis, x and y. I'm gonna divide into 2. For x, we will use the data. I'm gonna drop, as I told, I'm gonna drop the car name. I'm gonna drop car name, and also what I'm gonna do, I'm gonna drop, we have selling price, because here I will gonna be predicting the selling price here because it's a car price prediction model. If I have to, so I have to drop the selling price. And for y, here also, here sorry, here I'll not gonna be dropping it. I'll gonna take only the selling price. I'm gonna be using only selling price column. So what I did here for x dataset, I simply drop the car name and selling price here. So we are dropping these two, and the left other columns like year, fuel type, selling type, transmission, and owner, kilometer second driven, all will gonna be initialized on x. And for y, I'm gonna be only taking the selling price. So let's hit it. Okay, there is a error coming, key error. Okay, I think there is a name error over here. Simply checking selling price. Let's do a thing, copy here, paste over here. Okay, sorry, I didn't define the axis. We need to use the axis. For axis 1, it will gonna check the column side. Yeah, it's now working. So if I do print x, as you can see, without car name and selling price, all other columns are here. And let's check again y. So only selling price is here. So let's right now we have as you can see, after data import we did a simple EDA process, and after EDA process we jumped into feature extraction. Now we are gonna be moving to our model building process. Before model building process, let's check the data. From data we're gonna be predicting the uh, price here. We initialize the price on price data on y variable. So as you can see, so after watching it, what we can decide that this data is continuous. It it is continuous. It is not in categorical form. So for here, uh, if we are using any categorical data set, we have to use logistic regression, or other models are also here. But if we are using the continuous one, we have to use the linear regression. So for that, from all of those types, you can also use lasso regression is also there. But for later, then we are gonna be using for other for comparison, like we can use the decision tree, random forest, also SBM, super vector machine. Then later, then we're gonna be using it and comparing those on the model optimization step. So first I will gonna be using the for model building. For initial, I will gonna be using the linear regression one. So after dropping, what I'm gonna do here, I'm gonna split the training and test data set in the train and test data set over here. So here I'm gonna pick x train, x test, sorry, and for y we are using same y train and y test. And for that we're gonna be using the uh, train test split. Gonna be using train test split, and we will use the x and y. Okay, we initialize a small letter x y, and for test size I'm gonna initialize with 0.1, and after that random state will come. Random state I'll initialize as 2. Let's run it. So yeah, it is I think working. Let's try with x train, sorry, train. As you can see, for x train, okay, yes, for x train we are getting the split value. It is converted in the portion is test size on 0.1. If we go to another one like test, it is also be getting. As you can see, the row number is starting from 99. It is random because I gave here the random state like 2271133. If we go through x train, it is also randomly picked. Now I'm gonna be using the y train. As you can see, for y train we have only the present price, and it is also splitted into random state of test size 0.1. So here what I'll do now, I'll gonna be feeding this into our ML model. So first I'll gonna be taking the linear regression. So for linear regression, I need to initialize some over function here. So I'm gonna hitting scalar. Okay, so as we used the train test split, we need to initialize that also. The reason this train test split is working without initialization because I tested it for the same notebook before, so that is why it's showing okay. But for yourself you need to initialize that one. So I'll gonna be hitting from sklearn model selection. I'm gonna be import train test split. Okay, so after that I'm gonna also import linear from linear model. Import linear regression. Okay, I think everything is okay here. Okay, scale learn linear model. Okay, there is a issue over here, some mistake. It will be linear. Okay, it's working. So from here I'll gonna be calling the linear regression model from sklearn. So what I'm gonna do, I'm gonna here use lin regression. Well, for that I'm gonna be calling the linear regression. Okay, shit, there will be a function over here. As you know called it, we're gonna be fitting for x train and y train. We're gonna be fitting into the linear regression model. We're gonna take again and we're gonna use the fit function, and for fit function we're gonna be feeding x train and y train. I think it's working okay. Now as we defined our linear regression model here, we will gonna now go to evaluate process. Our model evaluation process. So here for model evaluation we're gonna do a prediction on our training data set. For our training data set we are going to make this prediction, and if we take our we're gonna be taking training data prediction here, and for this we're gonna define this linear regression model, and we're gonna use the x train. Okay, so we have to use predict here. As you can see, it's we successfully initialized that one, and now we'll for the confirmation we're gonna check r square error. And for that we're gonna take for error score underscore score. For error underscore score we're gonna use the matrix. For matrix R2 score, we're gonna take a Y trained. We can take Y train, and also for training data prediction, this one, simply copy it and we're gonna paste over here. So before running it, what we can do here, we have to write from scalar import matrix, sliced it, and we're gonna come back. So as we initialized the matrix library, we can use the matrix. From that matrix we can use the R2 score. Why the reason why we are checking the R2 score, it will give us some prediction percentage. Depending on the prediction percentage, we can see that how much it is predicting from the actual prediction line to our machine learning prediction line. So as we here initialize the error score, let's print it. So I'm gonna use print and r square error, and for r square error we have the error score underscore score. Okay, like there is error is coming for error score. Okay, see. Invalid syntax. Okay, there is something issue with syntax. Now copy it. Okay, the underscore here. Okay, as you can see, our r square error is coming 0.8799, nearby 88%. So as you can see, our machine learning model is predicting near of 88%. So right now what we can do over here, we can see the prediction line between the actual price that we are getting from the data set and the prediction price that we are getting from our machine learning model over here. So let's check it. So I'm gonna use the matplotlib visualization function over here. I'm gonna take a scatter plot, and we're gonna hit y train, which is the actual one, and our prediction that we are getting over here. And for x label, the actual price, and on y label we will get the predicted price. And after that we can initialize as plt.title, and for title we can write actual price versus prediction price versus prediction. Sorry. So after that we'll write plt.show. Okay, there is, sorry. Now as you can see, the scatter plot is showing over here some actual price versus prediction price. It's actually a little bit messed up because we got 88%, nearby 88% accuracy. So for example, our actual price points are going over here from that line, and the prediction price is going over that line. For the last one, we are getting the actual versus prediction a little bit gap over here, and without these 2 points, most of the points are nearby close. So as you can, for seeing this graph, we can tell that our machine learning building process is successfully done, because all those prediction are nearby going to the actual price. uh, uh, Except these 2 points, all those points are going to nearby. So yeah, we, as from this graph, we can tell that our model is properly working. So, and now what we can do over here, we can simply switch to model optimization. So for model optimization or other model building, we can also write here like select this. Okay, select this one, and we can simply write over here as using other model. For same linear regression model optimization, we can go back to our data set, and we can check the correlation values, which values are getting through the most correlated through SNS heat map. And after that, we can simply remove some values, and after removing those values, we will get the more prediction percentage. As you can see, these two are coming as outlier for the last two. We can also remove those two one. So without doing all of these things, we can check other models, like other models, how they are working working on the same data set. Sorry, this the same data set. Okay, so let's come back here. So for here, we can use like other model. So for other model, we need to see that it is continuous, it is supporting as continuous. We already used linear regression. We used it, so I'm gonna pick as used. What we can do, another thing, we can use decision tree. We can also use like random forest. Random forest also we can use. We can also use SBM, also known as support vector machine. All those works properly on a regression model. We can also use other things like some add a boosting technique, like we're gonna initialize it into another block, some boosting technique, some boosting technique. For boosting technique, we can use the add a boost. We can use add a boost. Also, we can use gradient boost. All those boosting technique will work perfectly for this data set, continuous data set. And SVM is there. Also, we can use KNN, K nearest neighbor. Also, we can use. So we can go with all those models. All those models also will be going perfectly. I think going perfectly for this kind of data set. So let's do it. So now let's jump into our Jupyter notebook again. So here I pasted a piece of code. So what it does, first I imported all the necessary libraries for like I called like linear regression, decision tree, random forest gradient regulator, and also add boost, and KNN for k nearest neighbor, also SVR, support vector regression. and for every model I use the regression type, and for every libraries I call the, if I called from sklearn, like sklearn from dot linear, sklearn from sklearn dot tree. And after that what I did, I splitted the data set. It is not needed again, because I did as the previous one, like test size equal to 0.1, random state equal to 2. And after that what I did, I simply write the code for linear regression, decision tree regressor, also the random forest. And if you see all the piece of code, it is written in the same format, like first one I am calling the uh, model like linear regression, and after that I am fitting into it, and then I using the prediction, using the prediction one, and also I am measuring the score. Same thing also happening over here, on dt decision tree. And after that random forest we are getting knn support vector, also add a boost, everything is going on same sequence. After that what I did, I am collecting the scores of each model. Like for ADA boost we are getting the AB score here, for gradient boost GB score here. So for linear regression LR score is there, and by getting all the scores in same, we are plotting a comparison. Here we are getting a bar plot, and for each bar plot we are defining for each score bar we defined some color like blue, green, orange. And after that, using a for loop, we are iterating between all of the scores, and we will be now plotting the bar. So let's run it. So after running it, we can see that all other models came successfully. There are two models, those who got some issue. Support vector is not working properly, like it came only 0.11, which is like 11%, and k nearest neighbor is somehow not coming, maybe minus 0.36. So we need to check it again. So if we left with these two, other is working perfectly. We got the highest using random forest, and I think gradient boosting we got the highest 98%, and second highest we got using ADA boost 94%. The reason why the boosting technique works perfectly, because it is a assemble model. It assembles all the ML model by dividing into chunks and getting the highest one. And after that we are also getting decision tree as 92% and linear regression as 84%. So I think that's enough for the comparison. And also so far we built this machine learning model perfectly. So on the last, on conclusion, we can tell that the random forest and gradient boosting technique worked well. Thank you.